Let's begin by reviewing the three states or phases of matter. And think about water here. So there are three different states that water can be in. Ice is the solid form of water. Liquid is the form of water that we drink. And then gas is the vapor form of water. So think of like steam in your shower. So here's a video that I made on my stove of an ice cube melting. This is a time lapse, so it's happening faster than it normally would. So you saw the solid ice cube turn into a liquid, and now the liquid is turning into vapor. Let's do a quick review of the three states of matter: solid, liquid, and gas. I've got some animations that I brought in to help explain this. So a solid has a distinct shape. If you remember the ice cube on the frying pan, when it was a solid, it took the form of a cube. It had a distinct shape. All of the molecules of water were tightly packed. And if you look at the animation under solid, you'll see that all of those molecules are very tightly packed. There's not a lot of room for them to move around. Our liquid phase took the shape of the container. So our ice cube melted and it started to form a pool in the frying pan. If I had more water in the frying pan, it would have taken the shape of that container. Think about water in a drinking glass. When you pour water into a glass, it takes the shape of the container. The molecules are tightly packed, but definitely capable of moving around. So you can take a liquid and you can move it around and it'll kind of take the shape of whatever you move it into. So there's moderate movement going on, whereas in a solid there was very little movement. The ice cube just kind of sat there, whereas a liquid will move around. And then finally we have our gas state. Gases take the shape of a container. So think about a balloon. When you're blowing air into that balloon, everything's very spread out and there's a lot of movement going on. So think about a gas state as like giving a kid Starbucks coffee. Kid's going to be super hyper, bouncing around, and that's what's happening with those gas molecules. They're moving around a lot, as you can see from the animation. So in the example where I had my ice cube on the frying pan, I was adding heat energy. So my ice cube went from a solid to a liquid, and in doing so, we say that it melted, and then from a liquid to that gas vapor, the water vapor, it was boiling, also known as evaporating. So that's when we add heat energy. When we remove heat energy, we're essentially reversing the process. So we're taking our water vapor and turning it into a liquid, which is called condensing. And then when we go from a liquid to a solid, we call that freezing. So hopefully all of these terms you're somewhat familiar with, and now you can associate those with the various phase changes. Here is a typical heating and cooling curve. Don't panic, these aren't as complicated as you might think. So this is a graphical representation of what just happened with that ice cube on the frying pan. So this is a heating curve, and as you can see, the temperature is increasing as the reaction progresses. Okay, so we're starting at this point right here. So let's say our ice cube started at a temperature of -40, and as we began to heat that ice cube, the temperature rose. So when it's on a diagonal, when our curve is on a diagonal, that's representing a change in temperature. It's a measure of kinetic energy, right? So as we're adding more energy, those molecules tend to move around a lot. And if you recall from physics, kinetic energy is energy of motion. Now, once we've heated our solid up, it reaches this plateau. Plateaus represent a change, our phase change, or a state of matter, or a change in the state of matter, rather. So we're going from a solid to a liquid. So on that plateau, our molecules are changing state from a solid to a liquid. So this represents a change in potential energy. Remember, potential energy is energy that's stored up. So a liquid, if you think about it, if you put ice cubes in a liquid, that liquid has energy stored up in it because it's got a warmer temperature. So that liquid's going to melt the ice cubes. So it's got energy stored up in it. It always represents a mixture of two states of matter. So if you think about an ice cube melting, as an ice cube's melting, you have part of the ice cube, the outer shell of that ice cube is a liquid, and the inner shell of that ice cube is still frozen. So it's in two states at once. So here's an example. What type of curve is this? Notice this is a little different than the previous example because the slope is going downward. So the previous example was a heating curve. This is going to be a cooling curve. What type of reaction is this? So if we're cooling, we are going to be giving off energy. So this is going to be exothermic. Let's try to identify on this graph where we're in the solid, liquid, and gas phases. Okay, so on the graph, we have a dashed line that's going across the graph, and we have two plateaus. Remember, those plateaus are where things are changing. So below the bottom plateau, since this is a cooling phase, or a cooling curve right here, below that bottom plateau is where we're going to be in the solid phase. Okay. Between the two plateaus right here, so from E to G, we are going to be in the liquid phase. And then finally, from A to C, so that's above the highest plateau, we are going to be in the gas phase. What is the freezing point? Remember, the freezing point is the point at which we're going from liquid to solid. So in the previous question, we identified that we were a liquid from E to G. So the freezing point is going to be the point that we are going from liquid to a solid. So the freezing point is going to be this entire part right here, right? And that matches up with 80 degrees. So in the previous question, we identified the freezing point as 80 degrees, and this one's asking for the melting point. This is kind of a trick question because both the melting and the freezing point are the same point, and this will always be the case, right? So at 80 degrees, we're both melting and freezing. What's the condensation point? The condensation point, remember, is where we go from a gas to a liquid. So we identified that we're in the gas phase here, and we're in the liquid phase here. So our condensation point will be from C to E, which is at 160 degrees Celsius. Now, just like with the freezing and melting point, the condensation and the evaporation or boiling point occurs at the same point. So again, at 160 degrees, we're both evaporating and condensing. At what point does the liquid begin to decrease in temperature? Now, this is kind of a tricky question because it says, what point does the liquid begin to decrease in temperature? So we know that we're a liquid in this basically from E to G. So the point at which we begin to decrease in temperature is right here at point E. Remember, kinetic energy occurs on the diagonals of the graph. This is where we're adding heat energy, which can be measured by temperature. So there are three of these on this graph. The first one occurs here from A to C, the second one occurs from E to G, and the third occurs from I to K. So again, the kinetic energy is changing from A to C, E to G, and I to K. Anytime you have a diagonal on the graph, that's where the kinetic energy changes. Where does the potential energy change? The potential energy is any plateau that we have. So there are two plateaus on this graph. We have one here from C to E, and we have another here from G to I. At what point is the substance 50% solid and 50% liquid? All right, now, on the graph here, we know that we are solid here from I to K, and we know that we are liquid from E to G. So you might want to think that this plateau here, the entire plateau, is when we are basically changing from liquid to solid. But on that plateau, we can isolate this exact point, H, as where it's 50% liquid and 50% solid. All right, for this last question, it says, at what point is a substance a mixture of gas and liquid? So on our first diagonal, we are in a gas phase because this is a cooling curve. The middle diagonal is where we're in our liquid phase. So the question says, at what point is the substance a mixture of gas and liquid? So remember, the plateau is when we are changing states. So point D would be the point where we're going to be a mixture of liquid and gas. And that's it. That's basically all you need to know about interpreting these graphs. Good luck and have fun.